Yeah, sound clear? Good morning, everybody. Today's topic is turbine lubricating oil system. In short, it is turbine lube oil system. Normally, where there is a rotating part, we use ball bearing or roller bearing or taper roller bearing. Suppose ID, FD fan, like this, boiler pit pump and other things. So we use roller bearing and ball bearing sort of things. But when there is a huge load, suppose turbine, and the most huge load is generator. Generators are heaviest in the power plant. So that is also rotating at high speed of 3000 rpm. Naturally, to carry such load with minimum friction, we need to go for a different bearing that is called journal bearing. That is not a roller bearing or something. It is called journal bearing. It is a very simple sort of bearing where, unlike the roller or ball bearing, there is a metal to metal contact. Whereas in journal bearing, At working condition, there is no such metal to metal contact. That is the beauty of such bearing, and it is a noiseless, very minimum noise, and loss is also compared to this ball bearing, rotor bearing, it is less. So, because it is running at higher speed 3000 rpm and it is achievable, suppose roller and other bearing can do its function at lower rpm as well as a higher rpm. At higher rpm, higher friction; at lower rpm, lower friction. But in general bearing, it is different. At lower rpm, it doesn't do the bearing properties doesn't develop. It develops with its speed. As it increases its speed, it has some mechanism. It will develop its bearing properties that I'll let you know about it. So that's why the journal bearing is used. Journal is nothing but the portion where the bearing surface is in contact with the shaft. The shaft portion where the bearing is in contact, it is called journal, whereas bearing is the load carrying surface below the rotor. So that is called bearing. Bearing means the itself, the load, bearing means it is carrying the load and transmitting it to the foundation. That is bearing. So turbine lube oil system means the lubrication has two major functions. One is to reduce the friction, that is the main objective is to reduce the frictional losses. Frictional losses is continuous. As long as it runs, its friction losses is there. We have to minimize this. It is in the range of megawatt. So the loss is also in the range of megawatt. So we have to reduce the continuous losses to the minimum. So that's why we are main objective is to minimize the friction. And second objective is the cooling. Cooling means the turbine is rotating at 3000 rpm. That too, the turbine shafts, it is handling a fluid of suppose 540, 600 degrees centigrade. Itself, it is in contact with the 600 degrees centigrade, the rotor is rotating. So the metal temperature is also achieving up to the 500, 540 like this. So the bearing also is coming up some higher temperature. So we have to design the bearing in such a way that the amount of oil flowing across the bearing should carry out the heat generated by friction as well as by heat carried from the steam. So both the heat to be calculated and the amount of oil to be fed continuously to the bearing and taken out, the mass flow rate of the oil to be calculated per bearing so that we can achieve the bearing temperature from 60 to maximum 80 degrees centigrade. Normal 60 to 70 degree temperature bearing temperature is maintained. However, the oil should be flown like this. So cooling effect is like that. The bearing temperature should not go more than 70-80 degrees centigrade. So we have a tripping or shutting down of power plant at higher temperature, bearing temperature. That is a protection is there. So we have to have a protection at higher temperature. Otherwise, the bearing will fail and it will be a disastrous system in the power plant. So we provide oil in the bearing. That is a lubricating oil. It has some properties, prescribed properties of there, and certain mineral oil, that is Indian Oil or some other company is supplying as per the specification. This oil has some properties. So we have to maintain these properties throughout the lubrication system, and viscosity is the major part of this oil. And temperature, you know that viscosity changes with temperature. So that's why we have to maintain a oil inlet temperature. It is around 40 to 42 degrees centigrade temperature. Oil is inserted into the bearing and taken out hot oil. And hot oil is again circulated to the tank. Again it is cooled and purified in the centrifuge. So that is in short the bearing system. And what is journal bearing, what is hydrodynamic bearing. There are two sort of, journal bearing has a two sort of system. One is hydrostatic bearing, one is hydrodynamic bearing. By that language you can understand, hydrostatic means in low speed or in static condition, you start rotating the turbine. So it is initially it is in contact with the bearing. So once you start rotating it with the huge load, the bearing surface will damage. So we have to lift the shaft by oil pressure below the bearing surface. We provide some high pressure oil and we lift the shaft a suppose fraction of millimeter or like this, so that metal to metal contact is avoided. Initial running condition. That is called hydrostatic lubrication, and that can be achieved by providing a high pressure pump, positive displacement pump, maybe gear pump or plunger pump like this. Mainly gear pump is used to provide such a high pressure oil, maybe at 130 or 140 kg per centimeter square. That oil is fed below the bearing surface at initial startup of turbine. Later on, as it achieves speed more than suppose 400, 500 or 600 RPM, this hydrostatic pressure is not required. It will develop its own pressure inside the bearing, and it will create a hydrodynamic pressure of the oil film, and that will carry the shaft automatically. That hydrostatic pressure is not required after that. So once it is achieving full load, there is no such metal to metal contact between journal and bearing. It will be floating inside with the support of a high pressure oil film. So that is developed by hydrodynamic lubrication. So that is the theory behind it, how we can achieve the hydrodynamic lubrication. I will let you know with some figures we have already drawn, because earlier I have taken class. Because during the classes, if we draw the figure, you cannot understand. So initially I have drawn some figure. I will explain it one by one. First, I will explain how the oil supply is given to the turbine for lubrication and cooling. For this, I will let you know. So one main oil tank is provided over, that is MOT. Again, that is called main oil tank. Main oil tank is filled up with number of 1,000 liters of more than 1,000 liters of oil over here with certain level is maintained. So on the top of the tank there are few pumps are mounted, centrifugal pumps. Suppose one GOP, that is positive displacement pump, which will provide oil, that is GOP. It is going this below this bearing surface level. At starting condition, it will lift the rotor, that is called rotor. So that is hydrodynamic. So the high pressure oil should not come back later. So that's why that energy is given. Suppose when this pump is not running, I will come to later this about this point. So jacking oil is provided at the below of this surface bearing point. That is jacking oil pump. EOP is somewhere it is called starting oil pump, or somewhere it is called auxiliary oil pump. The function of the pump is same. It provides the amount of oil, required amount of oil at required pressure to the. So this goes to the cooler, and outlet of the cooler is maintained at 42 degrees centigrade, and it is given into the header. So header means a distributor. It's simply header means in electrical term it will be bus. In mechanical it is called header. So it will give a header. From header we are connecting some pipes line to the bearing. So these are the bearing. Suppose this is 1, 2, 3, 4, 5, 6, 7. Suppose 7 bearings are there. We are providing with the pipes and for orifice. Orifice is an item with a flange having a certain amount of hole. We can change the orifice as per our requirement. Suppose larger amount of oil is required, we will give higher size orifice, and lower amount required, we will give some lower size of orifice. So amount of, depending upon the amount of oil to be fed into the bearing, so we are providing some orifice before entering to the bearing. So that means if you see, so that is the inlet line of the bearing, and that is the outlet line of the bearing. Outlet line bearing is somewhat larger because we don't need easy flow out is required. Inlet line, we have pressurized oil is given over here. Let me pressure, suppose it is 1.2 kg, 1.2 or something, 1.3 kg. The inlet is about 1.2 kg, suppose oil pressure 1.2 kg, and it is coming out freely normally. So now we can see this height is, this is inlet height, this is outlet height. A little bit of difference is there. So always the bearing inlet point is lower than the outlet point to ensure there is a certain amount of oil should be filled in the bearing. This outlet point should not be below this inlet point. So certain level of oil cannot be maintained. So certain level of oil to be maintained. So outlet point is somewhat higher and larger size. So at 40 degrees centigrade, we are providing oil inlet. So these are the drain of oil. After that means this drain out is connected like this. Oil is connected to the header, and header is designed in such a way by gravity it is flowing to the tank. Tank is placed below the turbine floor, so it is by gravity it will flow to the at the corner of this chamber. So whatever the dart will be given lower side, and it will oil will flow and go to the main chamber. Once it is going to the main chamber, it has some moisture in it, mainly moisture or some particles, some metal particles, bearing particles, maybe very micro particles will be available with this bearing. So to remove moisture as well as the particles, we have some filtration system or that or moisture removal system. So that is called centrifuge. Centrifuge means oil is passing through a centrifuge conveyor. It is a separate process. It will take the dirt oil and again it will give some. It is a closed circuit. It is not running continuously. Sometimes it is required will run. So centrifuge at high RPM. This RPM is around 9,000, 10,000 RPM. It is rotating the oil. There is a very simplified method. It will rotate at high speed. As you know, the oil is lighter than the water particles. So this water particle will be away from this center, and in the center the oil will flow, and this will be separated. So by this means we can separate the moisture mainly moisture from this oil, because continuous contamination of oil moisture, the property will be damaged. Amalgamation and other properties will be damaged. So that is a filtration system, and there is a EOP also mounted on this, that is battery operated emergency oil pump. But in any case, as long as the turbine is rotating, because once the turbine is rotating at 3000 RPM, once it is a protected or tripped, it is not coming up to the zero speed within few seconds. It will take some hours to come to zero speed. So as long as if some power failure is there, so oil supply should be available. So for the turbine protection, we are providing emergency oil pump, that is battery operated DC oil pump, which is run on protection. If this power is not available, EOP will be available to supply the bearing oil. At least some lubrication takes place and it prevent damaging the turbine rotor as well as the bearing surfaces. So we will come to the listen नहीं हो रहा है जब ऑफ करके रखा था later I will come to the question answer session. First listen to it. I will give some lecture because we are not sitting together in front of me, so that everybody cannot listen properly. First you listen what I am telling you. Later on I will come to the question answers. So oil is coming, and that is the lube oil scheme. Okay, turbine system. Emergency oil pump is providing oil at emergency so that bearings are not damaged. Once the one bearing is damaged, it is removing and replacing, means a shutdown is required. It is a very long process. So we have to be very careful about the bearing. So now what is journal bearing? I will come to it. What is journal bearing? In short, journal bearing is, have you seen the bullock cart, Belgadi? It is normal as it is. There is a shaft and there is a rotating part. Here it is, shaft is rotating and this bearing is standstill. On it, shaft is rotating. Very simple. There is nothing like this. but the difference is that the surface of the journal is very highly finished and the bearing is made up of some alloy element which is softer than the soft material. That means if sometime by any means it can be replaced. During maintenance, if there is any damage in the bearing part, we can change the bearing hubs very easily. So we intentionally made it lead-based alloy bearing surfaces so that it can be changed easily. Rather, the journal cannot be changed. It is a part of shaft, turbine rotor. It cannot be changed. So that's why we made it very softer material, which is in the bearing surface. So that is the bearing surface. You can see this is a sort of bearing surface. Lower hubs I am drawing it. I have drawn it. The holes behind it, it may be 1, 2, 3 holes, or maybe smaller bearing 1 hole, which will provide the jacking oil pump, jacking oil below this. So this is lower hub of the bearing. This is the upper hub of the bearing. Are you getting the point? The upper hub. The red point is the rotor inside. This is the rotor inside. This is the bearing surface. This is the length, and this is the diameter of the bearing. So we have to design the bearing length, diameter depending upon the load. Depending upon the load. If the load is higher, the length or diameter may be higher. If the load is less, the length may be less accordingly. Because the oil film which is created below this has some capability of load carrying capability. So we have to increase the oil film length. Or how oil film is different, I will. Now that is called, when at high pressure oil is provided, that is called hydrostatic lubrication. It is provided below this square during starting of turbine to avoid damage of the bearing. So this bearing surface may damage if it is in contact, it starts rotating. So we have to provide some high pressure oil, that is called hydrostatic lubrication. Now, how hydrodynamic lubrication takes place, I will come to it. Hydrodynamic lubrication takes place by its geometry of the bearing and rotor and the properties of oil. By the combination of both, the hydrostatic or hydrodynamic lubrication takes place. How? Suppose this is the bearing, lower hub, upper hub, and symbolically I am writing. This is the bearing, just this bearing, and this is rotor. Suppose at standstill condition, it will be touching at the bottom in a line. At this point, you are seeing a point, so it will be touching across this line. The shaft will be touching across a single line point. So shaft is touching at the single line. So this is the line over here. So it is touching. So now, before starting, we are providing some oil below this surface. So that is called static. Forget about it. Now slowly you start rolling the turbine in this direction. Now we are starting from 0 RPM. We are starting this rotor and this bearing has some clearance, few millimeter of clearance are there because we have to provide some oil space. So oil inlet and outlets are there. Oil inlet and outlets are there. So there is some clearance should be there. That means we are providing oil over here and getting out. So oil is filled over here. So now we start rotating over here. Once you start rotating, it will try to climb up over this surface. Once you rotating, it will try to climb up. So it is climbing up in this direction. So that means the shaft is shifting right side. Very clearly, the shaft is shifting right side because it is trying to climb up. But however, the oil is available over here. Oil is available over here. Once the oil is available here, that means the passage in between becoming larger to less over here. And due to viscosity, it is sticking to the surface and you are trying rotating it at a higher speed. What will happen? It will try to pump the oil inside it between the clearance. It will try to pump the oil available over here to inside it. That means, so if there is a passage is higher, the pressure is low. As the pressure is becoming very less, that means the oil pressure is becoming high at the below. So that is we are continuously pumping oil over here and releasing over here. That means there is a pumping inside is started due to the geometry and rotation of the surface. So the oil is continuously being pumped by rotation and it is being taken out from the other side. So that means if it is inlet and it is outlet, so oil is getting inside and outside. That means we are providing some continuous oil, and this oil pressure has become very thin. It is a micromillimeter in the range of a few fraction of millimeter. So that will be continuously giving oil. So once the pressure of oil is very high and also the rotor temperature is very high, this oil film is also getting very hot. So we have to remove this oil. Again, we push the fresh oil from here. So that's why 2 points are given, inlet and outlet. Right? So we are giving fresh oil and then it is pumping itself. We are not giving high pressure oil. It is pumping due to by rotation. So the oil film is, there is a OH form of oil, continuously high pressure oil form is. That is the pressure distribution of oil. Pressure. How the oil film pressure is developed over here. Initially, the pumping here is 0. As the thickness is getting reduced, the pressure is becoming higher. So that oil pressure actually holding the complete load of turbine, generator, or whatever. This very thin oil layer which is holding the load and also holding on the bearing surface. It is giving pressure in both the sides, but it is not allowing metal to metal touch between bearing and the rotor surface. It never touches. It never touches, and we are continuously achieving the. So once the full speed is achieved, so due to the pressure distribution, it will shift it in this direction, not in this. Initially, it will try to climb up. When the pressure is, because this is the high pressure, this is low pressure, because it is pumping out, that means low pressure. It is continuously pumping, so that means it high pressure. So slightly it will be left side. Once it is the direction of rotation is there, so it is the left side. So that is called hydrodynamic lubrication, which is achieved by rotation of the turbine rotor, and by this this film is holding. The oil film has a capacity to carry the load. So if the film load we know come to know, so we have to design the length as per the load of the weight we are carrying in the between two wheels. We know what is the weight of this turbine and generator, what is the load distribution among the bearings. So what the generator is the heaviest part, this is the heaviest part. So this bearing may be higher diameter, higher length. So this projected area, that is V into L, this is the bearing carrying area. The projected area we can calculate, and accordingly the bearing length can be calculated. Right? And the amount of oil we calculated depending on the heat dissipation properties, the specificity of the oil, and what is the heat coming in and heat coming out, and mass ms delta T. What is the temperature difference of oil you are calculating? Simple formula, by simple formula you can find out the amount of oil required for the bearing. As well, the cooling is important in that case. By the cooling method, we can calculate the amount of oil, and by load carrying capacity, we can calculate the diameter, length, and other things. That is the fundamentals of bearing design and lube oil system, hydrostatic and hydrodynamic lubrication system. Now it comes to question answer session. What is your question? So second session for ये सवाल जवाब रहेगा ना अभी अगर मिलेगा so we'll come to you write your question answer over here, so we'll come to the question answer session, what you understand, what is there. Thank you.